All right, so today we're going to look at the problem solving chapter. And the first concept we're going to look at is percent. I'm sure everybody is familiar with percent to some degree. Is basically parts of 100. Way to remember, percent is like a cent. A cent is 1/100th of a dollar. So parts of 100. So 40% can be written as a fraction, 40 over 100, or it can be written as a decimal, 0.40. And we'll be doing a little bit of this. Yes. So our first example here, we have 683 people out of 800 people state that they like dogs. What percent is this? So to find percent, you simply take the part, divide it by the whole, and multiply by 100. So in this case, the part is 683, and the whole, the total amount of people is 800. If we get our calculators out, maybe not. It serves me well. And we take 683 divided by 800. Which gives me 0.85375. And then when we multiply a decimal by 100, we just move the decimal place 2 spaces, right? Times, or we can just multiply it and we end up getting 85.375%. Everybody okay with that? I think that's all that's on that page. Okay, some more. Write the following values as percentages or percents. Well, this is the same as saying 3 divided by 4. So we have 3 divided by 4 times 100. 3 divided by 4 is 0.75 times 100, which is 75%. 3/4, otherwise called 3/4. 3/4 is 75 cents. 3/4 is 75%. On this next one here, we have a decimal. So I already have the decimal part. So just multiply it by 100. Multiplying by 100, you just move the decimal place 2 places to the right, and we get 1%. $0.01 is 1 cent, right? Same principle. Again, same thing here. 0.35 times 100 equals 35%. 35 parts out of 100. Any questions on any of these three? So again, here is the formula to calculate percentage times 100. A little note, remember that when doing computations, we must write percents as decimals. Your calculator doesn't have a key on it where you can multiply by a percentage. Unless you got a really expensive one. So next up, real world application of this stuff. Sales tax rate in Pensacola is 7.5%. Is it still that much, or did it go up or down? Anybody live here? So how much tax would you pay on a $319.99 purchase? Well, first we need to take this 7.5% and turn it to a decimal. Now to turn decimals to percentages, we went left 2 places. So to turn percentages into decimals, we go right 2 places. So 0.75% is 0.075. Now we want to know 7.5% of $319.99. That is simply multiplication. I have $319.99 times my percentage of 0.075 and 319.99 times 0.075 equals. And we get 23.99925. Now we're talking money here, so 2 decimal places. So I want to round to this decimal place. So I look to the next digit to the right. If it's 5 or more, I round up. So if I round up, this becomes 10, which means this is 0. I add 1 here and I get 10. This is 0. This goes to 4. So it's the sales tax on $319.99 is $24. Everybody good? So next up, we have the value of a 2004 BMW M3 dropped from 14,000 to 12,000 over the past year. What percent decrease is this? So remembering the percentage is equal to the part over the whole times 100. So in this case, what's the part? Correct. The amount of the drop, which is 14,000 minus 12,000, which is 2,000. Okay, so what's the whole? Got a 50-50 chance. 14,000. And always start with the beginning price. And we're going to multiply that by 100 to get percentages. Not 1,000, 100. So we take 2,000 divided by 14,000. And I get 0.1428571429. Multiply that by 100. In other words, move my decimal place and I get 14.29%. So this gives me an opportunity to discuss rounding. During calculations, I would round as little as possible. If you do round, I would make sure you show me what you rounded to. Because some of the stuff we do later on, rounding to the hundredths instead of the thousandths, can make a significant difference. The other thing I would say is on tests, show your work. Showing your work shows me that you put effort into the problem instead of writing a number down. It gives me an opportunity to point out where you went wrong if you miss a problem, and you get partial credit. Well, any questions on how we did that? If you don't ask questions, we'll get done early. That would be terrible. So that brings us to our next concept, which is absolute change and relative change. Based on the previous example, absolute change is the ending quantity minus the starting quantity, but take the absolute value of it. So it'll always be positive. Relative change is the absolute change over the starting quantity. This is a percent change, so the starting quantity is often referred to as the base of the percent change. So, suppose a stock drops in value by 60% one week, then increases in value the next week by 75%. Is the value higher or lower than where it started? Now, there's a way to solve this using just a variable like X. Personally, I like to make it easy on myself. So what I do is I say, let the original value be $100. Can be anything, so why can't it be 100? So now it drops 60%. So what is 60% of my original price, $100? Well, 60% is 0.60 of 100, which is 60. So now I've seen some homeworks turned in and a couple made this error. That means that the price is dropping by $60. So that means that the new price is 100 minus 60, or $40 after original drop, after the first week. Now it says, then it increases in value the next week by 75%. 75% of what? Of the $40. Very good. So making a note here, 75% converted to decimals is 0.75. And we want 75% of 40, which gives us 30. And that's the increase, right? There's a $30 increase. So the new price is this 40 plus 30, which is $70. So that's the new price. And the question is the value higher or lower? And it appears to be lower, right? This is where you have to be careful with percentages. It only dropped by 60% and then it went up by 75. So shouldn't it be more? So you have to be careful when dealing with percentages. Any questions on this? Everybody got it? Okay. A basketball player scores on 40% of 2-point field goals and 30% of 3-point field goal attempts. Suppose the player attempted 200 2-point field goals and 100 3-point field goals. Find the player's overall field goal percentage. So we have the 2-point shot and the 3-point shot. Okay, for 2 points, we have 40% completion rate, or 0.40. For the 3 points, we have 30% completion rate, or 0.30. Here we have, was it 200 and 100. So this is saying completed 40% of the 200 shots, the 200 2-point shots. So same thing. 200 times 0.40, which is what, 80? And over here, completed 30% of the 100. So 100 times 0.30 is 30. So how many shots did they complete? Well, you have 80 plus 30, which is 110. How many shots did they take? 200 plus 100, which is 300. So what's the percentage? Percent part over whole times 100, which is 110 over 300 times 100. So handy dandy calculators. 110 divided by 300 equals. Here I get 0.36666 repeating times 100 is, and we'll go 36.67%. I would say try to give me at least 2 decimal places unless it says otherwise. Any questions on this one? The next idea we come up with is a rate and a unit rate. A rate is a ratio of 2 quantities. A unit rate is a rate with a denominator of 1. You can drive 300 miles on a tank of 15 gallons. Express this as a rate in terms of miles per gallon. So I want miles per gallon. So I want 300 divided by 15. That's the rate. A unit rate, we would go ahead and divide by 15 and get 20 over 1. That would be the unit rate. In other words, we get 20 miles per gallon. A proportion is an equation showing the equivalence of 2 rates or ratios. So solve the proportion. 5 over 3 equals x over 9. Does anybody know how to solve these? You have 2 ratios equal to each other. Cross multiply. So I take 5 times 9. Five times 9 equals 3 times x. So 45 equals 3x. Divide both sides by 3, we get x equals 15. Any questions? You guys already know all this? So again, solve the proportion, we cross multiply. 6 times x equals 2 times 4, x equals 8, x equals 8 over 6. And unless it says reduce it to the smallest terms, just leave it. It's too easy to make a mistake. And I would definitely not go to decimal form if it doesn't say to, because in most cases, when we're going from fractions to decimal, the decimal is rounded at some point. So it's not as precise. This is the exact answer. This is the exact answer. This is close, but not exact. So unless it specifically says decimal form, leave it as a fraction. And unless it specifically says reduce the smallest terms, just leave it. It's too easy to make a mistake trying to reduce it. So we have a map scale indicates that 1/2 inch on a map corresponds with 3 real miles. How many miles apart are 2 cities that are 2 1/4 inches apart on the map? So here I am going to go against everything I just said and convert 1/2 to 0.5. And 2 1/4 is what? 9/4, which is 2.25. Okay. That good with everybody? So then 1/2 inch corresponds to 3 miles. So 0.5 is the 3, as 2.25 is to our unknown x. So we cross multiply, we get 0.5x equals 6.75. Okay. Then we divide by 0.5 and we get x equals 13.50 miles. Any questions? So some proportion problems may also be solved using dimensional analysis. The process of multiplying a quantity by rates to change the units. And then they give us a problem that doesn't require that. So if you recall from example 7, your car can drive 20 miles per gallon. So we're looking at 20 miles per 1 gallon. How far can it drive on 40 gallons? Oh, x over 40. Cross multiply, we get x equals 800 miles. How many gallons are needed to drive 50 miles? So in that case, we have 20 miles for 1 gallon. And I want to know how many gallons to go 50 miles. So again, cross multiply, we get 20 times x equals 1 times 50. Divide by 20 and we get 2.5 gallons. Any questions on those two? Please ask if you have questions. Still no. Okay. A bicycle is traveling at 15 miles per hour. How many feet will it cover in 30 seconds? So we have 15 miles in 1 hour. Now, one thing I need to do is get this to seconds. All right. So if I multiply this by 1 hour as 60 minutes, what this does is now I'm looking at miles per minute because the 2 hours cancel out, but I want seconds. 1 minute has 60 seconds. So now this cancels out. Now I'm looking at miles per second. Then I have 30 seconds. And over just the generic one. So now I'm to miles. But I have another issue. It wants to know feet. Does anybody know offhand how many feet are in a mile? I think that's right, yeah. So now we multiply by 5,280 feet per mile. So now the miles. So what am I left with? I'm left with simply feet. That's going to be my unit. So we multiply the top across. I have 15. And 15 times 1 times 1 times 30 times 5,280. Which is 2,376,000 feet. On the bottom, we have 1 times 60 times 60 times 1 times 1 again, which is 3,600. And there's no unit for the bottom. So if I take my 2,376,000, divide it by 3,600, I get 660 feet. So it travels 660 feet in 30 seconds. Any questions on how we did that? Okay, now we're looking at geometric shape. If we have a 12-inch pizza requiring 10 ounces of dough, how much dough is needed for a 16-inch pizza? So we're talking circular pizzas, although square ones seem to be the rage nowadays. And in case you were unaware, the formula for the area of a circle is pi r squared, r being the radius. So the first thing we need is the radius. Pi is constant, so we don't have to worry about it. So what is the radius of a 12-inch pizza? So what, 6? R equals 6. What about a 16-inch pizza? What's 16 divided by 2? 8. So now we need to find the area. So in this case, the area equals pi times 6 squared. 6 squared being 36. And here the area is equal to pi times 8 squared. 8 squared being 64. Now, I know what you want to do. You want to go and multiply. I got a button that says pi on it on my calculator. Why don't I do that? Don't bother. And I'll show you why. So this is the area of my 12-inch pizza. That requires 10 ounces of dough. So 36 times pi is the area over 10 ounces. How much dough I need is equivalent to 64 times pi over some unknown amount. Okay? So we have a proportion equation again. Cross multiplying, we have 36 times pi times x equals 10 times 64 pi. So the first thing I can do, well, let's do this first. Go ahead and multiply. I have 36 pi times x equals 640 pi. I can divide both sides by pi, right? So now I have 36x equals 640. Now all I do is divide 640 by 36. And I get x equals 17.7777 repeating, which I would round to 17.78 ounces. As I said, at least have 2 decimal places at the end. During calculations, try not to round. If you do, please let me know what you round to. That comes into more detail later on. Same type of problem. We have a website that says you need 48 50-pound bags of sand to fill a sandbox that measures 8 by 8 by 1. How many bags of sand would you need to fill a sandbox that measures 6 by 4 by 1? So we need 48 bags here. We're looking at volume. Volume is length times width times height. Should there be a problem of this nature on the test, I would give you the formulas. So it's the volume here is simply 8 times 8 times 1, or 64 cubic feet. And the volume here would be 24 cubic feet. And we have X bags. Same process. 64 cubic feet is the 48 bags, as 24 cubic feet is the X bag. Okay? Cross multiplying, I have 64 times X equals 48 times 24. Calculators out, 48 times 24. So 64x equals 1,152. Divide both sides by 64. And we get x equals 18 bags. Same principle, same thing. So any questions on proportion equations, rates, ratios? And so now that we've been solving problems, let's learn how to solve problems. So, how to do these things. The first thing you need to do is identify the question you're trying to answer. Now, not so much in this course, although it has happened, but I teach college algebra, and I've had students fill up a page or more of work and not answer the actual question. So please make sure you answer the question that is asked. Identify the information you'll need and the relationships you will use to answer that question. Like the pizza problem where we determined we needed the area of a circle. Try working backwards and create a solution pathway. If you're missing necessarily information, look it up or estimate. I guess the case of that would be the number of feet in a mile. If you have unnecessary information, ignore it. On any test we have, you will have everything you need. You might have some extra, but you'll have everything you need. And solve the problem following your solution pathway. So suppose your heart beats 80 times per minute. How many times does your heart beat in a year? So we have 80 beats in 1 minute. Okay? And our goal is we want beats per year. So there are 60 minutes in 1 hour, right? That cancels out the minutes. There are 24 hours in 1 day. So that gets rid of our hours. And for now, it's not leap year, so there are 365 days in 1 year. So that kills the days. Note we have beats and we have year. So now we just need to do the multiplication. 80 times 60 times 24 times 365 over 1 times 1 times 1 times 1. That's going to be rough. So we have 80 times 60 times 24 times 365. And we get a whole lot. Equals 4, 2, 0, 4, 8, 0, 0, 0. 42 million. $42,048,000 beats per year. That's all the beats. So any questions on that? A car is traveling at 100 kilometers per hour. How far does it travel in 5 seconds? Oh, we have 100 kilometers in 1 hour. Same process. We need seconds. So there's 1 hour is 60 minutes. So the hours cancel out. 1 minute is 60 seconds. So the minutes cancel out. And then I have 5 seconds. So the seconds will cancel out. So all I have remaining is kilometers. So I have 1,000 or 100 times 1 times 1 times 5 over 1 times 60 times 60 times 1. So I have 500 over 3,600. And I get 0.13 rounded to 4 decimal places kilometers. Everybody good with that one? Okay. This next one, living in Florida, this is one you probably should know. The answer to this. Not even thinking about it, but nobody remembers the old wise tale. So a flash of lightning travels at the speed of light, which is 186,000 miles per second. So for all intent purposes, instantaneously. Any lightning that flashes in our vision, we're going to see pretty much instantaneously. So this is what they're talking about, extraneous information. We don't really need that. It won't factor into the calculation. Next, it says the sound of lightning, thunder, travels at the speed of sound, which is about 750 miles per hour. If you see a flash of lightning, then hear the thunder 5 seconds later, how far away is the lightning? Does anybody know the answer? An old wives' tale. So it's traveled 750 miles per 1 hour. So there's 60 minutes. Oops, did that backwards. 1 hour is 60 minutes. That gets rid of the hours. 1 minute is 60 seconds. That gets rid of the minute. And we want 5 seconds. So that gets rid of the seconds. And now we just have miles. So I'm looking at 750 times 1 times 1 times 5 over 1 times 60 times 60 times 1. So we have 3,750 over 3,600. $3,750 divided by 3,600. Wait a minute. Oh, that's why. Hit the wrong button. 3,750 divided by 3,600. And we get 1.04 miles. You never heard that saying? 5 seconds to a mile? Yeah, you just did it. These problems aren't made up, they're real. Yeah, I used to hear that all the time when we were kids. Of course, I grew up here, so. Essentially, we were told if you hear see lightning and you hear thunder, count. See how far away it is and get you back home. So that's the last page. Go back to 16. Or did I skip one? Did I skip number 16? Oh, I did, didn't I? Shame on me. Thank you. Because there's a test question like this. I wasn't supposed to tell you that. So a store has clearance items that have been marked down by 50%. They're having to sell advertising an additional 30% off all clearance items. What percent of the original price do you end up paying? Now, this is kind of like the stock one. So again, why not make it easy on yourself? Original price, $100. Marked down 50%. So 50% is 0.50. 50% of our original price. This gets a little tricky. It's $50. Now, that's a $50 markdown from the original price. So we have 100 minus 50 equals 50. Now what happens here, I need to change this example, I keep forgetting, as people think it's this 50. But it's not, it's 100 minus 50, which is 50. Initially, it doesn't matter. However, now when we take this additional 30%, 30%, again being 0.30. So we take 30% of this 50. And that gives us 15. Then we take this 15 and subtract it from this 50. The remaining price is $35. Now, in this case, because it's 50%, it doesn't matter which one he uses. The problem is people tend to forget, and a test problem uses, I think it uses 60%. And that throws people. So be sure you do it correctly. So now we have $35, but we want the percent, which again is the part over the whole times 100. Well, our part is 35. Our whole is 100. And now you see why I use the 100. It's easier to calculate the percentage. Because essentially this and this cancel each other out. And we end up with 35%. Any other questions? Okay, so I'm going to turn off the recording since